Hi, we're continuing our series on cycle time reduction secrets. This is part 5 today. Mike Boyd's joining me. My name's Darren Harvell. We're here in our Experience Center room. That's a part of our commitment to you, to collaborate with you and to share information. We want to make sure that we answer any questions you might have today. So if you look in your top right corner, there's a Q&A there. Go to the bottom. You can type in your questions, and we're going to take those at the end and do our best to answer those. So Mike, you've shared a lot of great information in the previous parts that we've done. Today you're going to continue talking about some of that non-cut time savings.
That's right, reducing that machining cycle time, focusing on the non-cut time. We're going to talk specifically today about even more Makino specific M codes. And these M codes we're going to talk about today are M303, 304, 302, and M305. So specifically, the M303, 304 replace the standard M3 and M4, the spindle on clockwise or counterclockwise. And what these M codes allow you to do, they allow you to position at the same time the spindle's accelerating. And if you look graphically, the typical program format using M3, it's very sequential. The spindle comes on, the machine interlocks and waits before it positions. The M303, though, takes that and puts it in parallel and allows you to position as the spindle is accelerating. So these M codes take that serial process, put it parallel so you can really save some time.
Mike, all these M codes you're sharing, anybody can use these. You mentioned they're special Makino M codes. If you have a Makino machine.
If you have a Makino machine, these are standard on your machine.
Standard, okay.
They are. And then this last one we're going to show and talk about, this M305, it replaces the industry standard M5, which is spindle stop. Now there's not many opportunities that you have to use this just because you're not typically stopping your spindle in cycle unless you're at a tool change. But if you have any instances where you have to start and stop your spindle, if you're doing like back spot facing, things like that, where you have to stop, enter a feature, start your spindle back up, different things like that. This M305 allows you to, again, take that serial sequential process and put it in parallel. You can position while the spindle is decelerating. So again, saving time. So we're going to go out and we're going to show and demonstrate this out there in our integration bay.
Well, great. You know, seeing is believing, and that's what I like about this series is that you don't just talk about what's going to happen. We actually get to go out and show it to you. So we're going to run through it. You're actually going to see the cycle time savings firsthand.
Yes, we are. Let's
see it.
So this demonstration, we're going to show even more Makino special M codes. Specifically, we're going to show M303 or 304 and M305. Now what these M codes do, if you remember, they replace M3 and M4. Again, taking a serial process, turning it into a parallel process. So these M codes turn the spindle on and allow you to position as the spindle's accelerating. So the first demonstration, you're going to see the traditional M3, spindle on, movement. It's going to simulate drilling 2 holes and then record the time. The second part of this, the next step, is to implement the M303, and that is absorbing that spindle acceleration as you are positioning. Let me show you. First one is traditional M3, spindle on, move over, drill some holes. And I know this 851NX is fast, but that was a serial process where the machine interlocked waiting for the spindle to reach the programmed RPM. Now this next step is we're going to implement then the M303, where it absorbs that time as it's positioning. You see that movement? It positioned as it was accelerating. Again, simulating here, drilling a couple holes, moving back, recording the time. Let's take a look at those macro variables and see just how much time we save. So the first one is macro variable number 710 is where we recorded just the M3. That's at 9.2 seconds. The second one is 11, where we recorded using M303. That was at 8.8, so a little under a second savings. Again, looking at that across multiple changes, tool changes, you can realize a lot of savings. Let's go back to our program here now, and we're going to run the next part of this demonstration. And this is very important for me to tell you, that the format of your program makes a difference here. While we have the special Makino M codes, M303s, M304, you can also get the same effect if you want to change your post processor just using M3, but placing that M code on the same line as your positioning. And I'm going to show you that. There's no difference using M3 or M303 when you put them on the same line as your G0 positioning. So the first one is using M3 on that same line. Start it up. You see the movement over as the spindle is accelerating. Again, simulating drilling 2 holes. And that was M3. The next one we're going to run, same program format, but M303. Again, you're going to see that acceleration happening as you are positioning. And there was no difference. And we're going to confirm that when we look at our macro variables. The macro variables being 712 and 713. There's virtually no difference in the time. And again, I wanted to point that out to you because if you wanted to change your post processor or go back and change all of your CNC programs to move that spindle on command onto that same line, you'll get that same effect as M303 before your positioning. Now the next demonstration here is I'm going to show you is that M305 and that spindle stop. If you ever have that needed in your cycle where you're doing like back spot facing, you're starting and stopping the spindle, this will come into play, making that a parallel process where you stop the spindle and position at the same time. So let me show you. So this is the movement without M305. So we're going to come over, we're simulating the machining cycle, turning the spindle off with M5, and it waits. The next one, we're going to use M305, and you're going to see that time absorbed as it moves. Again, simulating drilling a cycle. We're drilling a hole, a couple holes. M305 absorbed as we moved. Now let's take a look at the savings on our macro variable list. M305, the first one on 714 is at 11.5 seconds. 715 is 9.3 seconds. That's a substantial cycle time savings. Again, if you have multiple places where you're starting and stopping the spindle in cycle, you can use M305 for a parallel process.
Mike, that was a great demonstration of Makino special M codes. Some of the other value that we add for our customers where we've developed these special M codes, I love that you're able to demonstrate them. We're gonna take some time now to answer some of your questions. If you look in your top right corner, there's a Q&A. Go to the bottom, you can type in your question. We're gonna do our best to answer them. Hello everyone, hope you enjoyed that and thanks for sticking around for some Q&A. Mike, thanks for taking the time. Appreciate you joining us today.
Thank you.
So Mike, one of the things that's been interesting as we've done this series is that we've had some great questions that have come in and you've been able to follow up directly with those people that are asking them. And it's started a conversation. People have been able to get some good information from you. One of the things I wonder if people know about is that we have that type of availability for that expertise for our customers if they call into our customer support service line. So I'm going to just put up a question here I want to ask everybody. Have you ever called Makino's customer support services? And that's the 1-888 Makino 4. And if you called that for applications help, we have a lot of people that understand that's the number that they can call in for service on their machines, but they can also use that number to call in if they have an applications problem or a question or an issue they need help with, and we're able to get back to those customers. And I know, Mike, you've been involved in some of those, and other members of your team. What are some give me an example of the type of call you might get through that line?
Well, we get a number of questions in from customers from previous turnkey projects, for example. Looking to improve even further on cycle time. Maybe they're trying to implement a new tool. They want to pick our brain on programming techniques, speeds and feeds, different things like that, and we'll engage and get involved and help them out. We do have a full team of very experienced application engineers here, and yeah, we're ready to help.
Okay, so the polling results, it looks like that we do have some people that did know that and some people who didn't know that. So just want to point that out and have everybody keep that in mind, that this great resource that we have through this expertise, you can get access to that. So remember that number. So Mike, we want to look at a question here that we have. They're asking about, as we mentioned, part 1 through part 4. We've done this series and we've had them posted, and people are wanting to know where can they get access to those. So one way you can do that is if you go to handouts up in your top right corner, you'll see that there is a article with parts 1 and part 4 links. It's listed there. So if you download that, that's going to take you to an article that at the bottom of that has links to parts 1 through 4. But also, if you go to makino.com, you can go to our resources. You can find these 4 located there, along with a lot of other great content, other webinars on other topics. And one other location to point out to people is if you go to YouTube, the Makino channel, you can find them there. And again, there's lots of other great videos and information there. So check those out if you haven't seen those parts before. Okay, Mike, I've got a question for you here. You talked about M302. That was on your chart, and they want to know more about what does M302. You focused on the other M codes. On the slide, there was a comment about confirmed spindle speed. So question is, describe a little bit more about what that means and how that works.
Yeah, I guess I didn't really get into M302. And what that is, that is telling a machine to confirm that the spindle RPM is at the commanded RPM before you actually get in to your cut. Obviously, important there that you're up to speed before you actually start making chips. So it looks at that confirmation. So there's some times that cycles are so fast, the positioning is so fast, you're at a high RPM that you're in position before the spindle actually gets there. And this prevents you from actually machining while the spindle is accelerating. On that same note, though, we're talking about cycle time reduction secrets. A little known FANUC parameter 4022 actually tells the machine to interlock all the way up to a certain percentage of commanded RPM. It doesn't interlock all the way up to 100% based on this setting. And typically the setting will be a percentage within 100% that the machine will continue on. So for example, our machine standard, the default setting is 15. So 15%, rather 85% of commanded RPM, then the machine will continue on. So that's another secret, if you will, that not many people know about. But going back to M302, that is the command that tells the machine to make sure you're at that commanded RPM before you start engaging in part.
Okay, great. And thanks for that additional tip. I learned something new every time we do these, Mike. So that's one I didn't know. I appreciate you explaining that. Another question we have is asking, are there any Makino machine models that these M codes are not standard on? We talked about the fact that if you have a Makino machine, these M codes are standard, but are there any models or any machines that they're not?
Well, these are geared around our horizontal machining centers and our Pro 6 or Professional 6 controls. Really, any Pro 6 control has these M codes available. Um, you got to watch on the verticals. I'm not 100% sure on the verticals how these M codes react. However, I know on the horizontals, Pro 6 and Pro 5 have M303 and 304 available. Something to note though is the format. I was talking about the programming format, putting the M3 on the same line as your positioning, that working like M303. And some of your older Pro 5 models, that is not the case. And the M305, which is the spindle stop command, that is not available either on the Pro 5. So, there's some vintage of controls that some of these M codes have been more recently developed, and they're not available on some of those older models.
Okay, so I would suggest anyone who has a specific question about a particular machine or model, email us, ask that question, or like we were talking at the beginning of this Q&A, we have that 1-888 Makino 4 number. Call into that and we'll get you an answer. And Mike, we also were demonstrating the M5. You talked about how that special M code can be used for operations like back spot facing. And question here is, can you explain why that might be necessary to stop the spindle? Some people may not be familiar with that. Can you just kind of explain what you meant by that and why you'd want to stop the spindle in cycle in an operation like that?
Yeah, sure. When you have a situation application where you're back boring or back spot facing, where you have to bring the tool into a smaller diameter than what you're cutting, those cutting tools are designed eccentric, meaning the cutting end of the tool, the end of the tool is off center. And that is so you can fit it through that smaller diameter off center. So in order to do that, the spindle has to be stopped. So when you're positioning over to that feature that requires a back spot face or a back boring, you could use M305 to absorb that deceleration time. And then once you get into position, obviously, then you turn your spindle on and you perform your back spot facing or back boring operation. But that's one instance where you could use M305 to save some time.
Okay, that makes sense. The way you explained that, I appreciate that. And one of the other things that you were talking about was the fact that with M303, M304, that you can use the M03, M04 if you program it on the same line. So question here is, well, then what's the advantage of the M303 and M304 that are the special M codes that Makino provided? What's the point of those if you can do it by just programming on the same line?
Yeah, great question. So if you have, for example, thousands of existing programs where you have the M3 on a separate line and you want to take advantage of these Makino M codes, you can do a simple find, replace, edit, quick edit in your programs. You're not going through and really doing major edits, just replacing the M3 with the M303. Moving forward on your post processor with new programs, you can certainly put the M3 on the same line as your positioning, or you can take advantage of the M303 and keep that same format.
Okay, yeah, so that could save a lot of time the way you're describing that and make things a lot easier. What about with some older models? Is there any differences in the ability to program on the same line?
Yeah. I mentioned earlier some of the older models. You can program on the same line, but it will interlock until that spindle is up to speed, and then continue on after that. So like I said, that some of your older Pro Fives, they're not able to use that functionality.
Okay, so in that case, it'd definitely be an advantage to use the special M codes, the M303 and M304.
Absolutely.
Makes sense. Okay. All right. So want to point out to everybody, we had mentioned earlier in the handouts, the article that we had there when we were making sure everyone had access to the parts 1 through 4. That was one spot. And I also just want to point out to everybody that there's the presentation slides there. We always get a question about, are the presentation slides available? You can download it there. And there's also contact information you could download. So appreciate everybody joining us. Mike, thanks for putting the demo together and being available for Q&A. Really appreciate it. Thanks.
Thank you.